number 9. We're going to work number 9 2 different ways. So kind of split this down the middle here. So we can have 2 different ways to look at this, okay? So when I look at number 9, everything's in terms of cosecant. So although cosecant is a reciprocal, I don't know that I want to start with reciprocal identities. Like, it's fine to leave it in cosecant the whole time. I have a bad feeling I said cosine at the beginning, but cosecant, obviously. But if you look at the numerator, what kind of situation do we have going on in the numerator that we've seen like a bazillion times? Difference of squares. Beautiful. So let's go ahead and take care of our difference of squares. And that's going to give me cosecant squared x minus 1 over cosecant squared x. We all agree with that? That's the way difference of squares works, no matter what it is, right? Okay, so now I have 2 squared things. So I want to look at my Pythagorean identities. Most of the time, you're trying to condense 2 terms into one. So even though I could apply it to the numerator and the denominator, I think really I just want to see if I can do something with the numerator first, since it's 2 terms. So by looking at what you have that cotangent squared theta plus 1 equals cosecant squared theta. That's on your reference chart, right? So you got a couple of options here. You can substitute this in for cosecant squared, and that's fine. Or you can look at this and use a little bit of reasoning. What does cosecant squared minus 1 equal? So this is cosecant squared minus 1. If I just subtract 1 over there, doesn't cosecant squared theta minus 1 equal cotangent squared? So we can just straight up replace the numerator with cotangent squared. So cotangent squared x over cosecant squared x. Okay, everybody good with that? So now, I don't know that I want to, do Pythagorean in the denominator or anything, because I definitely don't want the denominator to be more than one term if I don't have to. But I think I need to go down the ratio and quotient avenue here. So cotangent is what over what? Cosine over sine. So cotangent squared can become cosine squared x over sine squared x. And then cosecant squared can become 1 over sine squared. Do we agree with all that? And then our goal is to simplify this. So this becomes a keep, change, flip situation. So I have cosine squared x over sine squared x times, then that's reciprocal of that is sine squared x over 1. The sine squareds cancel out, and I am left with cosine squared x. Everybody agree with that? Questions about that? All right. So let's look at this a different way, okay? One's not better than the other. I just want you to see that there are 2 ways to go about this. We would start the same way. So we'll still start with cosecant squared x minus 1 over cosecant squared x. Okay? So instead of using the Pythagorean identities or the quotient identities or anything right now, what's the thing I told you you're not always going to think to do right at first? I told you it's a good strategy, but it's not going to be the first thing you think of most of the time. Remember what that was? Got a fraction. If you have a fraction, you can put fractions together. You can also take them apart. So that whole splitting the fraction thing, which again is not always in the forefront of your mind, and I understand that, but let's try splitting this fraction. We can split this. So we can split this into cosecant squared x over cosecant squared x minus 1 over cosecant squared x. Right? That's legal to do because that's how common denominators work. All right, so what is that first fraction going to give me? 1, right? Just reduces to 1. And then what's 1 over cosecant? sine. So this is sine squared x. So it's 1 minus sine squared. Then looking at your yellow card, what is 1 minus sine squared? Cosine squared. And there is my answer. Okay? So 2 different ways to do it. Like I said, one's not better than the other. You may disagree and think, oh, well, the second one's shorter. Well, great. You're not always going to have that much of a choice or be that much of a difference, but you also have to think to do it. Not that that would always be, I mean, sometimes maybe I split the fraction, then it's the longer way. Like, you don't know when you get started. So just, you know, whatever makes the most sense to you, I just want you to see different ways of doing it. Okay? Are we all good with that? What questions you got? All right, so let's look at number 10. Can I split this second fraction? No, because you can't split the denominators, but you can split the numerators. I don't have any squareds. I don't have any much that's real obvious to do, except that I know that tangent can become sine over cosine, so let's start there. Let's make tangent into sine theta over cosine theta. And that'll be plus cosine theta over 1 plus sine theta. Okay? Everybody okay with that? All right, so now I have 2 fractions, all in terms of sine and cosine. So I think I want to combine my fractions. So in order to do that, I need a common denominator. My common denominator would be cosine theta times 1 plus sine theta. So then when I put this together, that means this first fraction has to be multiplied by 1 plus sine over 1 plus sine. So that means I get sine theta times 1 plus sine theta. Plus, then this fraction has to be multiplied by cosine over cosine. So then this would be cosine squared theta. Okay. Everybody with me? I have 2 places where I could distribute. Remember, we don't do just stuff just because we can do stuff, all right? In the numerator, I feel like I'm going to have to distribute to clean that up in some form or fashion. But we don't always want to do a ton of things at once either, because sometimes we lose an option in another place. So we're going to start by just distributing in the numerator and leaving the denominator alone. So my numerator becomes, when I distribute, I'm going to get sine theta plus sine squared theta plus cosine squared theta all over cosine theta times 1 plus sine theta. Everybody with me? Any questions about where anything came from? Do you have any thoughts as to what we could substitute here? Do you see anything that looks familiar that you might see on your reference card? Yeah, what is sine squared plus cosine squared? 1. So that whole, those 2 terms right there, that equals 1. So my next step can be sine theta plus 1 over cosine theta times 1 plus sine theta. Right? Now, is sine theta plus 1 the same as 1 plus sine theta? Yes. 2 plus 3 is 3 plus 2, right? Is sine minus 1 the same as 1 minus sine? That is a no, and that we'd have to factor out a 1 or something. But this is fine. These are identical, so I'm going to cancel those out. See, if I had distributed here, I would have had to factor it back out. Now, that's not just because I've done this problem, but maybe I get to here, and then maybe I see, oh, you know what? I need to actually distribute now. But just like wait until you think you actually have to do it, because things might match up and you're just causing yourself more work. So this becomes 1 over cosine theta. And what's 1 over cosine? Secant. So this is secant theta. What questions do you have? Anything? All right. Let's look at this last one. Number 12. All right, so I've got some cube stuff there. We haven't done anything with cubes yet, but even if it's on that chart, remember, we're not looking at it yet if we hadn't talked about it. And And I got some squared stuff in there too, but what else do I have going on that I know for sure I can take care of? What's going on in the numerator? What can I do? Factor out the GCF. What's my GCF? Sine cubed. So this is sine cubed x times cosecant squared x minus 1 over cosine cubed x. Okay. Everybody with me? So I do have some the Pythagorean, but I also have sine over cosine, right? So the other time we had this, where I don't remember if it was on the front or on the back. I might have done it. It was on the front. So if you look at this, we had a situation similar to this right here. And I went ahead and wrote it like this to make sure I didn't lose anybody, and then we made it in the tangent. But you don't have to write that step, so I'm going to skip that step right here and say I know since I have this sine over cosine here, and because it's all multiplication, right? If there was, oh, not right there. There I can't do it. Let me back up. I circled the wrong thing. That I could not change to tangent, right? Does that make sense? Because I have two terms. Okay, circled the wrong thing. It's right here where I do, and because it's being multiplied by that, I'm good. So I can make that into tangent cubed x times cosecant squared x minus 1. All right, so then I would look at that cosecant squared. Notice I'm not trying to do a bunch of stuff all at one time and, a couple of steps at once. Bad idea on this, okay? Real bad idea. When you look at your yellow card, do you have something that what could cosecant squared minus 1 be equal to? Cotangent squared, good. All right, how are tangent and cotangent related? They're reciprocals, but this doesn't straight up give me 1 because this is cubed and this is squared, right? But what I can do, just to make sure I can wrap my mind around this correctly, tangent cubed x, ignore that, my fingers are, I'm getting better at not writing all over the place, but no, not plus, oh my gosh. Okay, times 1 over tangent squared x, right? So then now I can cancel 2 of those with 1 of those, and that just leaves me with tangent x. What questions do you have? Anything? Good? Okay, beautiful. All right, so go ahead and tape that in if you haven't already. You already have the worksheet. If there are there any questions on the first few that I asked you to try on your own? Did nobody actually try them? Probably not. Okay.